In this video, we shall take a look at multicollinearity using R. First, let me show you a synthetic example so that you appreciate why we need to consider multicollinearity seriously. I am creating my data set with three regressors. X1 is simply 1 to 100. X2 is essentially 3 times X1 with a little bit of jitter added to it. And X3 is just X1 square. So basically I have only X1 and X3, and X2 is the same thing as X1, 3 times X1. Now I am going to create my data in this way: y equal to 1 plus twice X1 and 0.05 times X1 square, which is X3. And with it I am adding the epsilon error. Now I will fit my model LM, which is y x1 plus x2 plus x3. Just observe that now I am using x2. So x2 we know is basically not needed because we ourselves created the model. I know that x2 was not here, but we pretend that being the statistician we are unaware about exactly how nature created the data. So we have thrown in x2 also. We are taking the coefficients, and I am doing this 100 times in a loop. Every time I am using the same x1 and x3 and x2, but I am using fresh randomization. So I create fresh data from the same model, and I am also accumulating all the coefficients. So I am taking the coefficients and then are binding them with some variable which I have called TM. So I am starting with an empty matrix, then I am adding the estimated coefficients as row after row in it. So after the entire thing is done, it will be a matrix with 100 rows. Each row will store the estimated coefficients. So let's run it and we'll see what we get. So let's quickly take a look at TMP. It has got 100 rows as expected, and we have got the columns. The first thing is the intercept, coefficient of x1, coefficient of x2, coefficient of x3. So these are the things. And now just observe how weird this thing is. We know that x1 and x2, they are just multiples of each other, a positive multiple. x2 is 3 times x1. Yet the coefficient of x1 is 8 point something and coefficient of x2 is minus 1.9. So very weird. Now look at here. Here both the signs are the same. And here this is smaller and this fellow is larger. Here this is larger and this fellow is smaller. Yet you expected that one would be something like 1/3 the other or some such thing. No such thing. Okay, now let's just understand how bad the thing is by computing the variance of these things, of these estimated coefficients, and you will see that x1 has variance of the order of 10 to the power 2, so it is something like 128. This one also has a pretty high variance. Compare with it x3, which has not inside any multicollinear relationship, its variance is so very, very small. So you understand that things that are locked in multicollinear relationship, they are much higher. These are much higher variances. Yet the thing which is outside the multicollinear relationship, that is estimated in a much more precise way. So you understand why multicollinearity is a dangerous thing and we need to tackle.